Welcome everybody, and we are looking at factoring polynomial expressions lesson 2. So we are looking at factoring trinomials in this form here, x squared plus bx plus c. What I want to do is skip the first couple of pages. I think I just want to simplify this lesson so that we totally understand it. I'm going to keep skipping to page 191. So I'm not even going to use this. I just have written up here because I wanted to use this space here. So this is the form of trinomial that we're looking at. And this is a really important lesson. This is one of the bigger concepts you learn in grade 10 is factoring trinomials in this form. So here's the form here that we were talking about at the start, x squared plus bx plus c, where b and c are going to be integers or numbers. So some examples of this, just so you understand, are x squared plus 4x plus 16, or x squared minus 3x plus 5. Apologize for the pen. I don't know why it's being like that. It's kind of bleeding a little bit. But anyways, there is a way to factor this. We just looked at factoring by pulling out a greatest common factor. But with most of these, we can't pull a greatest common factor out. They're set up in a way that we actually have to do a different method to factor them. So we are going to factor them by inspection. That is kind of by looking at it and figuring it out. So in order to factor x squared plus 8x plus 12, we need to find two numbers which multiply to the positive 12, multiply to 12, and add to positive 8. So what are two numbers that multiply to 12 and add to 8? Well, how about 6 times 2? 6 times 2 is 12, and 6 plus 2 is 8. Cool. If you can do that, then you're totally good, and I'm going to show you what we're going to do with that in 1 second here. So let's try that again. In order to factor x squared minus 13x plus 12, we need to find two numbers that multiply to positive 12 and add to negative 13. Sometimes it's hard to find these numbers, and there is a good strategy to use if you're not sure. So we'll talk about that a little bit more. I'm not going to go over that one, but we will. I'm just showing you that we need to find two numbers that multiply to the constant and add to the middle term. So we're going to do a little bit of practice with that. So let's complete the tables to find two numbers that give the sum and the product. Remember, sum is an addition, and product is a multiplication. So the first one's done for you. Two numbers that add to 12 and multiply to 20, 2 and 10. 2 plus 10 is 12. 2 times 10 is 20. How about two numbers that add to 9 and multiply to 20? Well, what are some numbers that you can multiply together to get to 20? 1 and 20, 2 and 10, 5 and 4. And that's what it is right there, 5 and 4. Or 4 and 5, however you want to write it. 5 times 4 is 20. 5 plus 4 is 9. Two integers that add to 4 and multiply to 4. Well, 2 times 2 works pretty well. This one is where it gets a little bit harder. So a lot of times you can't just do this right away in your head. So we're looking for two numbers that add to negative 9 and multiply to positive 18. And this is where you have to remember that if you multiply a negative and a negative, you end up with a positive. If you multiply two negative terms, you get a positive. And if you add two negatives, lots of time you're going to get a negative. So I know 6 times 3 gets me 18, but 6 plus 3 gets me positive 9. So that doesn't work. But negative, that's not a negative sign. Negative 3 and negative 6 work. Negative 3 multiplied by negative 6 gives me positive 18, and negative 3 plus negative 6 gets me negative 9. So let's try that with the next table. I'm going to start showing you some strategies. So if you have two numbers where you don't really see it right away, it can be a little bit tricky. So what I like to do is I start with the number I'm looking for multiplication. So here we're looking for two numbers that multiply to 14. So what I like to do is I make a little chart on the side. 14. 1 times 14, 2 times 7, and that's it, right? So now there's got to be some factor pair here that adds to negative 15. Doesn't seem to be working. But what if, because we know we have to multiply to positive 14, what if we had negative 1 multiplied by negative 14? Well, negative 1 plus negative 14 gets me to negative 15. So those are my integers right there. Negative 1, negative 14. All right, now we're looking for the product negative 6, or two numbers that multiply to negative 6 and add to negative 1. So this can be a little bit tricky as well. We know that if our product is a negative, that means one number is going to be positive and one number is going to be negative. So we're looking for two numbers that multiply to negative 6. So we can have 1 multiplied by negative 6, negative 1 multiplied by 6, 2 multiplied by negative 3, and negative 2 multiplied by positive 3. And now you just have to go through there and figure out, well, if I add those together, which one adds up to negative 1? And then you can see here 2 plus negative 3 is negative 1. So there's my two numbers right there, 2 and negative 3. That's supposed to be a comma. It looks like a J. So just be careful with the negatives. Remember, if you're multiplying two numbers and you need to get a positive number, that can either be a positive multiplied by a positive or a negative multiplied by a negative. So now you have to look at, well, what are you trying to add to? If you're trying to add to a negative number, then you're probably multiplying two negative numbers together. But if you're multiplying to a positive number, or you're multiplying to a positive number and you're adding to a positive number, then they're both probably going to be positive integers. That's kind of what they're talking about here. So now you're probably thinking, okay, I know how to do this. It can get a little tricky if the numbers get big, but I'm just looking for two numbers that multiply to one number and add to another number. So what are we going to do with that? Well, I'll show you. So here we go. Here's some good examples. Let's do A. I have x squared plus 8x plus 12. So now I'm looking for two numbers that multiply to 12 and add to 8. So what are those going to be? Well, two numbers that multiply to 12. So, I don't know what happened there. Let's just erase all of that. Two numbers that need to multiply to 12. Well, I'm going to make my little multiplication table here. 1 and 12, 2 and 6, 3 and 4. All right, which of those add to positive 8? There we go. Positive 2 and positive 6. So now you can write your factors as x plus 2 multiplied by x plus 6. And that's it. You factored that trinomial. If you wanted to test it, you could FOIL that and see what pops out. So you start both your brackets always when you're factoring a trinomial with a single variable. So if it's x squared to begin with, then you get x times x. And then it's just a matter of filling out the digits in each factor. So one factor is x plus 2, the other one's x plus 6. Let's try the next one. We are looking for two numbers that multiply to positive 12 and add to positive 13. Luckily, we've already done a multiplication chart for positive 12 over here. So now we just need to look through those three sets of factor pairs and figure out which one matches. So I'm looking for two numbers that add to 13. Well, it looks like 1 plus 12. So my answer is x plus 1 and x plus 12. Now, if you wrote that opposite, if you wrote x plus 12 multiplied by x plus 1, it wouldn't matter. It's the exact same thing. When you're multiplying numbers, the order doesn't matter. All right, so now we have x squared minus 13x plus 12. So I'm going to start by writing my x and x. So I'm looking for two numbers that multiply to positive 12, but add to negative 13. So be careful of that negative. That is a bit of a hint. So we're looking for two numbers that multiply to 12, add to negative 13. Because we actually forgot three sets of factor pairs in our 12 multiplication chart. Because I know when I multiply negative 1 by negative 12, I get positive 12. If I multiply negative 2 and negative 6, I get positive 12. And same with negative 3 and negative 4. So I actually missed three factor pairs. And you can see that to add to negative 13, negative 1 plus negative 12 works. So what you're going to do is now you're going to write it in as x minus 1, x minus 12. Awesome. Let's do one more. Which one should we do? Let's do two more. Let's do E, and we will do F as well. Here we go. E, I'm going to just write my brackets in, Y and Y. So now I'm looking for two numbers that multiply to positive 4 and add to positive 3. So I'm going to come to the side and make my multiplication chart for 4. 1 multiplied by 4, 2 multiplied by 2, negative 1 multiplied by negative 4, and negative 2 multiplied by negative 2. So, do any of those add to positive 3? 1 plus 4 is 5? No. 2 plus 2 is 4? Nope. Negative 1 plus negative 4, negative 5? No. Negative 2 plus negative 2, negative 4? No. Okay, so now we have to double check that we have all of the factor pairs. 1 times 4, 2 times 2 was the only ones for 4. If this is the case, and there's not two numbers that work, then this might be not possible. There are actually ways to factor this, but not through inspection. So we cannot factor this the method that we've learned. So it's not possible. And sometimes that's going to happen. You'll notice your questions in your textbook say factor where possible. And that means that some of them are just not going to be possible. x squared plus 27x plus 50. Let's do the next one. So we're going to have x and x. And we are looking for two numbers that multiply to 50 and add to 27. So let's do our multiplication chart. 50, 1 times 50, 2 times 25. Don't think 3 works. I don't think 4 works. 5 times 10. So do any of those add to positive 27? And you can see here 2 plus 25 add to 27. So we are going to get positive 2, positive 25. And if you wanted to check, take your answer and FOIL it. And you can see if you did it right. FOIL to check. So if you're doing a quiz or a test, you should be able to double check that you've got the right answer every time. Sometimes they're going to give you a trinomial where you have a constant in front of the x squared term. If that's the case, you cannot factor by inspection. So what you need to do is check for a common factor. Can you remove that 4? So if I were to factor a 4 out, is 32 divisible by 4? Yes. Is 48 divisible by 4? Yes. So what you can do is, let's factor that out, 4. And what we're left with is, oh, come on. I don't know what's happening. There we go. Sorry, if you factor a 4 out, you are left with x squared. Negative 32 divided by 4 is negative 8x. And 48 divided by 4 is positive 12. And now by factoring that 4 out, you can see we are left with a trinomial in the form that we want it in, so we can factor by inspection. So now when I write my brackets at the bottom, I'm going to write 4x bracket, bracket, x, bracket. I can't forget about that 4. That 4 is still part of the problem. So now I'm looking for two numbers that multiply to 12, add to negative 8. So I'm multiplying to a positive number, but I'm adding to a negative. They should add to a negative number, which means my numbers are probably, the two numbers I'm looking for are probably going to be negative. So multiplying to 12 is 1 and 12, negative 1, negative 12, 2 and 6, negative 2 and negative 6. And you don't have to do this multiplication table every time. If you can see it right away, then you can just write it down. But when you do get stuck, it is good to know how to do that. So we are looking for two numbers that multiply to positive 12 and add to negative 8. And you can see right here, negative 2 plus negative 6 give us negative 8. So now we are going to go x minus 2, x minus 6. And that's your final answer. Yay. One more, just for good measure. Again, you can see we have a coefficient out front. So we want to try to factor that out. But I also noticed something else here. So you got to be careful. This is an x cubed. And we have an x on the constant term. So we need to fix all of this. And we're going to try to fix this by removing a common factor. So I need to remove a 3, and I need to remove an x. So you can see I can pull a 3, and I can pull an x out. So if I remove a 3x from the first term, 3 divided by 3 is 1. X cubed divided by x is x squared. And then 21 divided by 3 is 7. X squared divided by x is x. And then 30 divided by 3 is 10. And x divided by x just cancels out. Now that I've pulled a common factor out of that, I'm left with a trinomial in the form that I want it in x squared plus bx plus c. So I can rewrite this, hopefully, if the factoring is possible, in the form 3x and then multiplied by 2 factors. So now I'm looking for two numbers that multiply to 10, add to 7. They're both positive, which is nice. So numbers that multiply to 10 are 1 and 10, and 2 and 5. And 2 plus 5 equals 7. So 3x multiplied by x plus 2 and multiplied by x plus 5. That is our answer. And you can double check that if you want to by foiling those two brackets and then multiplying that 3x through to see if it ends up looking like that. That is factoring trinomials. It sometimes seems simple when I do it on the lecture, but it's really important that you practice because it's a lot different when you do it yourself. So make sure you practice a lot. You will be factoring trinomials in this course in Pre-Calc 11 and in Pre-Calc 12 constantly. So this is a skill that you need to know. Of all the skills we're going to learn, this is the one I would love you to be really, really strong in. So if you need help, please ask. If we're in class, if we're not, email me and I can absolutely help. This is a big one. So I appreciate you watching. Don't forget to like and subscribe.